All right, gang, here is a quick review of how to convert into base units for metric prefixes for use in physics and other sciences. Here we got a problem, 59 nanocoulombs to regular coulombs. This is a unit of electric charge. The problem with the coulomb of electric charge is that it's ridiculously big. You never get a full coulomb of anything unless you have it getting struck by lightning. So in a lab, microcoulombs, nanocoulombs are much more likely. First, write out the problem. There's no substitute for it. Don't skip this step. You won't be able to follow the directions if you haven't gotten it written out. There, 59 nanocoulombs to coulombs. Uh-oh, lost the sig figs. If there's a decimal point, the zero counts. If there's no decimal point, the zero doesn't count. Now the directions say multiply on the left. Write this out first. Then divide on the right. On the left, is there a prefix? Yes, it's nano. Check the chart, memorize the chart, or notice that not even the AP wipes the memory in your calculator. Nano is 10 to the negative 9th. Check the other side. Is there a prefix? Is there anything in front of the base unit of coulombs? No, no prefix, just one. There. 59 times 10 to the negative 9th divided by 1. You can do this one in your head if you are quick. 10 to the negative 9th, that's 9 powers of 10. 59 50s. That's 1 power of 10, specifically 10 times 5. All right, negative 9 powers of 10 plus 1 would be 5.90 times 10 to the negative 8th. If you type this into your calculator, you will also get 5.90 times 10 to the negative 8th. If you want to use machine language so that your calculator gives you the right answer all of the time, use the EE, not the lowercase e, this key right here for scientific notation. And if you type this into the calculator, it will also give you the correct answer, which is 5.9. Wait, there's a decimal place. That means somebody had decent equipment and they made a very good measurement. Make sure you know how good their measurement is. 0.90 times 10 to the negative 8th, full coulombs. That's ready to go in the formula with Coulomb's law because it's in base metric units. Here's a problem where you do need to take care in your denominator so the calculator doesn't simply lie and give you the wrong answer. This is 320 megabytes to gigabytes. You want to see if there's enough room for this file on your flash drive. Again, write the problem out. 320 megs to gigabytes. What's the difference? This problem only had one prefix. This problem has two. So again, write the signs before you get fancy. You multiply on the left. You divide on the right. Mega is, check the chart, 10 to the 6th. Giga, check the chart, that's 10 to the 9th. Again, you can do this in your head if you don't have a calculator. 6 powers of 10 here. 7, another power of 10. 8, there's another power of 10. 8 in the top, 9 on the bottom. 9 wins by much, by 1. That's going to be 32, 1 power of 10 on the bottom. That's going to be 0.32. If you type this into your calculator, you may get the right answer, but it is much safer to use that E key and use scientific notation. 320 times 10 to the, you don't need the times, you don't need the 10, you don't need the, times 10 to the 6, divided by 1 times 10 to the 9th. This is machine language. It will understand when you type it in, and it will always give you the right answer of 0.32. What about the 0? No decimal place. This isn't exactly 320 megs. It's probably like 319.1, maybe 316.9. It might even be as high as 324. They didn't really check the file. They just remember more or less how big it is. 320 megs, okay? It's one real short live video with animation on your phone. It's about 0.32 gigabytes.